Welcome to Lesson 12, Simplify Radical Expressions. We're in algebraic concepts. So, simplifying radical expressions may not come up in an Algebra 1 class. This may be an Algebra 2 section. Definitely, this will be going over. This may be a little early. I just put this in here just to go over because this really deals with numbers. This could have been in numbers and operations, but radical expressions really, because it's in the expressions, I put it with the algebra. So that's why I chose that. All right, here's our objective. You can stop, pause, and read through those. So rules and notes for you. So please, if you've forgotten radicals and radical symbols, please go back and watch one of my exponent videos in numbers and operations. I was really torn about this, but since we are dealing with expressions, I figured I will put these here. Let me get a darker pencil. All right, so this is negative 2 times the square root of 108. So how do we solve this problem? Basically, what you want to do is look for, you're going to factor these. So these come back down to factoring. You want a perfect square factor. And if you forgot what your perfect squares are, those are the numbers down a diagonal of a multiplication chart. So please grab your multiplication chart so that you can have it and go down the diagonal. So you have to factor 108 into a perfect square. So you got to think 1, 4, 9, 16, 25, 36, 49, 64, so on and so forth. Well, I know that 9 times 12 makes 108. So we leave the negative 2 on the outside. And what you do is you're going to break this down into factors. You can always break the square root down into the square root of 9 times the square root of 12. Now 12 breaks down into 4 and 3. So now we have negative 2 times the square root of 9 times the square root of 4 times the square root of 3. Wow, 108 could have been 36 times 3. And then think about that. So negative 2 times the square root of 9, which is 3 times the square root of 4, which is 2. The square root of 3 is an irrational number, so we just leave it as the square root of 3. And so now we just multiply the numbers on the outside. 2 times 3 times 2 is negative 12 root 3, or negative 12 times the square root of 3. Okay, so let's look at our next example, and let me make the square root all the way over. So in the computer, it will only make this little funny sound. And let's see, we're going to have to factor 147. So let's try 147 divided by 3. All right, so 3 goes into 14. 4 times 12, we get 27, which is 9. So now 9 times 3 is 27. So 147 is 3 times 49. And we're going to separate all of these factors times y. And we're taking the square root of everything. So what you're going to want to do is take the square root of 3 times the square root of 49 times the square root of x squared times the square root of y. You may be asking yourself, how do I know that this is the square root? There's no number on here. If this was anything other than the square root, there will be a little number on the indices, a 3, a 4, or whatever. But because there's no number, it's understood to be the square root on top of the square root. And that's something that you'll see in later videos in the future. For now, we're only going to deal with the square root. So getting back to the problem. The square root undoes squaring. So we know that 49 is 7 times 7, or 7 squared. So what the square root does is take away your square. So watch what pops out. So the square root of 49 is 7. X squared, this root crosses out the 2, and we're left with x. And then times the square root of 3 times the square root of y. And so what we have is 7x times the square root of 3y, or 7x root 3y in short. So that is how we solve this problem. Okay, so those were our two examples. These are simple, simplifying radical expressions. We'll get into more complicated ones in later videos. Okay, so this is the square root of 400. Remember to look for your perfect square factors. A square root of 75. A square root of a squared, b to the 5th, c to the 6th. And there we go. So try these 4 problems and break them down into their roots, and let's see what we come up with. I will see you at the end of the video for the recap. Okay, so the square root of 400. Well, we have 4 times 100. Or maybe you know that the square root of 400 is 20, but let's do it this way with the factors. The square root of 4 is 2, and the square root of 100 is 10, and 2 times 10 is 20. Okay, so if you are in the 8th grade, you should know your squares and square roots up to 20, maybe 25, but 20 would be a good number to know. And you should know your cube roots up to 10. This would be very helpful for science, solving math and science problems. You know, one cube, 2 cube, 3 cube, 1 squared, 2 squared, all the way up to 25 squared would be helpful to know. All right, let's look at problem 2, the square root of 75. Well, I know that the opposite of the square root of 25. I know that 25 breaks down into 3 times 25, and the square root of 25 is 5 root 3 negative. So we have negative 5 root 3 as our answer. Okay, 4 times the square root of a squared, b to the 5th, c to the 6th. Now, this looks a little complicated, but remember, we're looking for our squares. So watch how I break this down. 4 So a squared times b squared times b squared times b to the first. We know that when we multiply the same base, you add the exponent. So b to the fifth is b squared times b to the first power. And c squared is c to the sixth power, c squared times c squared times c squared. And so what do we pull out? So the square root of a squared times the square root of b squared times the square root of b squared times the square root of b times the square root of c squared times the square root of c squared times the square root of c squared. And a 4 in front of all that. So now we know that the square root takes away the 2 in all of these. So these will cancel. This will cancel. This will cancel. This will not. The third b will not. This c will cancel. This c will cancel. And this c will cancel. So what do we have? We have 4 times a times b times root b times c times c times c. And going back and doing some exponent math, 4a b squared c cubed root b. So anything that's not under, let me write this better. This is supposed to be a b and it looks like a 6. So let's write this a little better. Okay, that is b. So now, anything, see how I put the answer is in alphabetical order. A first, B second, C third. Even though these are higher exponents, it goes A, B, C first. Then you worry about your exponents. Now, you might have thought to put the root B next to the B, but anything under the square root goes at the end. So this is the proper way to write radicals. And finally, our final problem. Okay, so we have 189. Let me think. So 189 breaks down into, let's try to divide it by 3. We got 6 times 3 is 18. 3 times 3 is 9. All right, so we got 3 times 63. Well, I don't see any perfect squares yet because 63 is not a perfect square. So let's break 63 down into what? 7 times 9. Oh, look, 9 is a perfect square. So now what I'm going to do is write all of these squares out. So we have square root 3 times square root 7 times square root 9, because that makes up 189, times m squared times square root of m times n squared times n. And let's see what pops out. So 3 is not a perfect square. 7 is not a perfect square. 9 is. So 3 comes out. M will come out because the square root cancels the square. The square root cancels the square. We got another m coming out. This m does not come out. This n does. So what are we left with? 3m squared n. Then we got root 3 times root 7 times root m times root n. And what we're going to do is combine everything under one radical. So 3m squared n times the square root of 3 times 7 is 21, m times n, mn. So 3m squared n root 21 mn, or 3m squared n times the square root of 21 mn. However you want to say it, but this is the proper way to write it, with everything outside of the radical in front of the radical symbol or the square root sign or the root sign, and anything under the radical is combined again into one term. So all of this is one term because it's all multiplied. Just a little pickup. So this is the end of this video. It might be kind of long, but there was a lot to say. If you like what you saw, please Please subscribe, hit the notification bell, share. Thanks for watching this video, and I will see you in a future video.